So this is classifying numbers. We're going to be classifying rational numbers. And you actually learned about this in sixth grade. And rational numbers are every number that you've known so far in your entire life. Rational numbers are fractions, decimals, integers, whole, and natural numbers. So rational numbers can also be integers, whole numbers, and naturals, like I said before. They have different characteristics to be identified as an integer, whole number, and natural. So an integer is a number that is not a fraction nor a decimal. It can be negative and or positive. So it goes from negative infinity to positive infinity as long as it's not a decimal or a fraction. Whole numbers are kind of like integers, but they do not include negatives. So whole numbers are all positive numbers, including 0, that are not fractions nor decimals. And natural numbers, another word for natural numbers is counting numbers. So natural numbers, since it's called counting numbers, are 1, 2, 3, 4, because you naturally start counting with 1, 2, 3, 4. So they also do not include negative nor fractions nor decimals. So I like to play a game with this diagram that you see because it gets harder and harder to get to the center. Okay, so since it gets harder and harder to get to the center, you start losing off some numbers. So I like to basically ask myself, it's like a club. So rational numbers is a line. So everyone's staying in the line for rational numbers. They're trying to see if they can get into the integer room. And then they want to get into the whole number room. And then they want to be the VIP room, which is the natural numbers room. But they got to get past the bouncers. To get past the bouncers, you got to see if you meet the criteria. So we're going to go through all these numbers to see where they belong. So first number is 0.875. So it's a decimal. First things first, every single number is rational. So every number can go into this box. Okay, but now you got to see if they can go into the integer box. So this is 0.875. Well, this is a decimal. No decimals can go into integers. So 0.875 has to stay in rational. Okay, so now we're going to go on to 0. 0 can go into rational because all numbers are rational. And so then you're going to ask yourself, can it go into integer? Well, since 0 is not a decimal nor a fraction, it can go into an integer. Because integers are all positive and negative whole numbers. So since this is a 0, this is a positive, so this can go into a whole number. So now you got to see if it can go into a natural number. So 0 cannot go into a natural number because natural numbers are counting numbers. So 1, 2, 3, 4. So this does not include 0. So 0 has to stay here. So since 0 is staying here, that means it's a whole number, but it also means it's an integer, and it also means it's rational. So every time it goes through the box, it gains that name. So it's rational, integer, and whole. So now we're going to try 17. So 17 is a rational. And so since it's not a fraction or a decimal, it's an integer. And since it's positive, it also is a whole number. But since it's not 0 and it's positive, it's also a natural number. So 17 is everything. 17 is natural. 17 is whole. 17 is an integer. 17 is rational. It is all of these. So that's the reason why it gets to be in the middle, because it's the best of the best. So now we're going to do 15 over 3. Well, 15 over 3 is a math problem. So you can do 15 over 3, which equals 5. So 15 over 3 is 5. So even though 15 over 3 looks like a fraction, it can be reduced down to 5. So 15 over 3 is rational, but it's also an integer because it's technically not a fraction, because when you solve it, it equals the number 5. And we know 5 is a whole number, and 5 is also a counting number. So 15 over 3 will be in the center. So now we're going to try -2/5. So -2/5 It starts off to be rational. So negative 2/5 is a fraction which cannot be reduced. So it stays a fraction. And since it's a fraction, it cannot go be an integer. So negative 2/5 stays like that. So it stays in rational. So it's just rational. So now we have negative 29. So negative 29 goes to become a rational number. Since it's not a fraction nor a decimal, it gets to go down to an integer. Okay, so it's an integer. It's trying to see if it can become a whole number. Well, it can't become a whole number because it has a negative. Since this is a negative number, it gets to stay with integer. So negative 29 is just an integer and rational. Now we're going to try the number 9. 9 is rational, is an integer because it's not a fraction or decimal, is a whole number because it's positive, and is a counting number because it's not 0. So 9 is natural, whole, integer, and rational. So now we're going to try 0.777. Okay, it goes to be a rational. It cannot be an integer because it's a decimal, so it has to stay here. So 0.77 is just a rational number. Now we're going to try negative 1.4. Well, negative 1.4 is negative, but it still cannot be an integer because it's a decimal, so it has to stay here. Now we're going to try 8 3/4. 8 3/4 is a fraction, it's a mixed fraction, because even though it has a whole 8 on it, it still has the attached fraction part. So 8 3/4 is only a rational number. And that is how you classify rational numbers. And we're going to work on this a little bit more. So let's go to the next slide. So this is your vocab. So rational numbers are all numbers that you know in 7th grade. Integers are positive and negative whole numbers. Whole numbers are numbers from 0 to positive infinity, not including fractions or decimals. And natural is from 1 to positive infinity. Think of counting numbers. You start 1, 2, 3, 4. Okay, so now we have this box. So what we're going to do is we're going to put a check mark for what category they belong to. And remember, they can belong to more than one category. So 10. 10 is rational. Let me change that color so it looks more. 10 is rational. Or we can put an X. Let's put an X. So 10 is rational because all numbers are rational. 10 is an integer because it doesn't have a fraction nor decimal. 10 is a whole number because it's not negative. And 10 is also natural because it's not 0. Okay, let's try 0. 0 is rational. 0 is an integer because it's not a fraction or decimal. 0 is whole because it's not negative. But 0 is not natural because you cannot count 0. Okay, let's try negative 3.2. So negative 3.2 is rational. Oops, there we go. It's rational, but it is not an integer because it has a decimal on it. So that's it. So now 9 over 3 can be reduced to 3. So 9 over 3 is 3, which is also rational, which is an integer, which is a whole number, which is natural. It's everything. Negative 12. Negative 12 is rational. And negative 12, since it's not a fraction or a decimal, is an integer. But cannot be a whole number because it's negative. So that's our table. As you notice, all numbers are rational. Okay, only some of them can be integers, whole, and natural. For a number to be natural, it also has to be a whole, it also has to be an integer, and it also has to be a rational. So it has to meet all of those criteria. Hey, let's do a true or false. So true or false, and reading right here, all integers are rational. So if I go back, every integer I had here that I put an X by had to be rational first. So my statement is asking, are all integers rational numbers? That's true. To be an integer, you first had to be a rational number. So that is a true statement. B, all integers are whole numbers. Okay, well, let's go back to our chart. Did every integer become a whole number? No, they did not. Not all integers are whole numbers. You can say some integers are whole numbers because some of them do become whole numbers. Because if an integer is not negative, it will become a whole number. But if the integer is negative, it cannot be a whole number. Okay, why don't you pause the video and try these true or false questions? Okay, tell whether the statement some rational numbers are integers is true or false. So that's false. Excuse me, that's true because some of them, because not all rational numbers become integers, but some of them do. So this is true, and I'll type out the reason. Because some rational numbers are integers because they are not all fractions and decimals. And let's make this grammatically correct. So we can say, well, why are you not going up there? So some rational numbers are integers because they're not all fractions and decimals. Okay, and then you can skip number 7 because I don't need a real situation. We're just talking about classifying today. Okay, so what you're going to do is you're going to move on to the next slide and complete. You're going to go on to the other Google slide that's posted in Google Classroom, and you're going to complete the homework. Actually, this week, I'm sorry, it's a Google form. So please go to Google Classroom and complete the Google form homework posted on the same assignment. Come on. Okay, so your homework today is a Google form question. If you have any questions or need any help, please contact me, and then I'll hopefully work it out with y'all. Thank you, guys.